Good morning, ladies and gentlemen. Welcome to the next video on kinematics, following on from our last easier introduction in the previous video. This video we go through more notes and a couple of specific examples. Now, you don't need to stress about writing down all of the notes. I'll give you a printed out version, but you're welcome to copy them down if you'd like. Alright, firstly, just to recap, when we talk about motion in a straight line or rectilinear motion, what we're talking about is where we have an origin and then some type of point which is either to the left or the right of the origin. And we say that if this is st, meaning the displacement is positive, it's to the right. If it's equal to 0, it's at the origin. It's negative to the left of the origin. So, scrolling down. Velocity, as we mentioned last video, is change in distance divided by change in time. Displacement 2 to minus displacement 1 over change in time is equal to the average velocity. What's happening there is we're taking a curve, which might well be the motion, and taking 2 points on it and saying, well, that there is the average velocity. When we move this point back here, we're going towards the instantaneous velocity, which, as you can imagine, is a first principles type of problem or just calculus. Alright. Similarly, acceleration is the rate of change of velocity. So, same sort of setup here, but this time changing velocity, not changing displacement. You don't need to get overly stressed with all these different formulas. The important thing is to understand the principle. Alright, so let's look at this question here. Particle P moves in a straight line with a displacement function of st equals s squared plus 3t take 2. And if you're wondering what that looks like in a graph, the graph is just to the right. Find the average velocity from time equals 1 to time equals 3. So what that is saying is time equals 1 is about there, time equals 3 is about here. They want to find the average velocity, meaning the slope between those 2 points. So what we have to do here is work out what s of 1 is. S of 1 is 1 plus 3 is 4, take 2 is 2. S of 2 we don't need because it's asking us for s of 3. S of 3 is 9 plus another 9, take 2 is 16. So therefore, velocity, this is a velocity, is equal to change in displacement over change in time. Those triangles or deltas mean change in. And that's saying 16 minus 2 over 3 minus 1. That's the difference in distance divided by the difference in time is 14 over 2 equals 7 meters per second. Yeah. So that is the average velocity from time equals 1 to 3, and you can sort of imagine on this slope here, that could well be a slope of 7, meaning for every 1 across, we go 7 up. 1 across, 7 up. Alright, part B. Find the average velocity from time equals 1 to time equals 1 plus h. Alright, so time equals 1 looks like this. We are 2 meters to the right of the origin. Time equals 1 plus h is a little different. So that way we have to sub in here. That is 1 plus h squared plus 3 lots of 1 plus h minus 2. Alright, let's expand and simplify. 1 plus 2h plus h squared plus 3 plus 3h minus 2. Note that didn't come out to 1 squared plus h squared. You have to remember the FOIL or the proper expansion. Alright, then collecting right terms. H squared is the only one. Then we have plus 5h. And then constants, we have 4 minus 2 is positive 2. Alright, so the displacement in 1 plus h is that. Displacement after 1 is 2. Alright. Now, let's find the average velocity. So average velocity is this, is s of 1 plus h, take s of 1 over 1 plus h, take 1. Sub in h squared plus 5h plus 2 minus 2 over 1 plus h take 1 is just h. This equals h squared plus 5h over h is just equal to h plus 5. So that, in meters per second, is the velocity, the average velocity, between 1 and 1 plus h. And if it feels like a first principles problem, that's because it is. Because the second part, in C, asks us exactly the same question. 1 plus h, take S1 over h, and that's what's happened here. But here we're looking, in part C, we're looking, well, what happens as the limit of h tends towards 0. And we can see that if we follow the algebra out here, well, we're looking at the limit. We could have started there, but I'll just bring back our answer from here. As h plus 5, as h approaches 0, well, that's just equal to 5 meters per second. So interpret the result, or comment on its significance. That there is the instantaneous slope of this, or the instantaneous gradient of this function at t equals 1. Or we could say it is the velocity of this function when time equals 1. And you can imagine that would not be as steep as what we found in part A. So part A was the slope between those two, and we found that a slope of 7. The instantaneous slope, the tangent there, is 5. Alright, find the average velocity from time equals t to t plus h seconds and interpret that. That will give us the velocity function. So it's essentially finding via first principles the first derivative of this, and if you work it out, which you're welcome to, you'll come to 2t plus 3. That will be equal to the velocity function, so vt. Alright, more notes. So here we explained in the previous video that we differentiate to get from displacement to velocity to acceleration. Note that SO, VO, and AO are what give us information about the position, velocity, and acceleration of the particle at time 0. So at time 0, the particle might not be standing still, it might be moving, it might start to the right, start to the left, etc. Alright, sign interpretations. I wouldn't get too hung up on these. Mr. Crawley and I are not sure to what extent they're in the course. The course outline mentions you should know and understand rectilinear motion, but doesn't go into any details of how much you should know. So this may be a case of TMI, too much information, but hopefully it makes some sort of sense. So the interpretations of ST, displacement, when it's equal to 0, the point is at the origin. I've said this before, located to the right, located to the left. Velocity, you don't have to worry about the proof, but velocity here, if the velocity is equal to 0, then it's instantaneously at rest. If velocity is moving to the right, the velocity is positive. If it's moving to the left, then the velocity is negative. AT, similarly, if it's positive, it's increasing. If it's negative, it's decreasing. If the acceleration is 0, what might be happening is the velocity might be a max or a min, or it might not be changing. So acceleration of 0 doesn't mean the particle is standing still, it just means it's not changing its velocity. There is a table there. Once again, I'll give you the printed out notice. Alright, here. So, here's the question. Read it through, and then we'll go through it. Alright, st equals t squared minus 4t plus 3. Find expressions for the object's velocity and acceleration and draw sign diagrams for each function. Alright, so here, velocity is equal to s dash t. So, velocity function here is 2t minus 4. Alright, and therefore acceleration is just equal to 2. Alright, not too bad so far. What we want to look at is sign diagram for each. Well, here, the sign diagram for velocity, that there will equal 0 when t is equal to 2. When it's less than 2, it'll be negative, it'll be positive. Here, that's saying the acceleration is constantly 2, meaning it's just going to be positive. Alright, and you should have Vt here. You should have t here and t here. Alright, find the initial conditions and explain what is happening to the object at that instant. Alright, initial conditions. Let's look at displacement. So SO is equal to 3, i.e. it is 3 meters to the right of the origin. VO is equal to -4, meaning it is travelling 4 meters per second towards the origin in that instant. AO is 2 meters per second squared, meaning it is accelerating in this direction. That sounds odd, that it's instantaneously travelling to the left but accelerating to the right. What that means is its velocity will decrease and decrease and decrease as it's going left, and then we'll start heading right. Alright. So describe the motion at time equals 0. So at time equals 0, we want to describe the motion of the object. We're looking at, time equals 2, V2 and A2. Because note it says the motion, you don't have to explain where it is, you just have to describe how it's moving. V2 is 0. A2 is 2. We can see that by subbing in the values of the functions there. So this here means it is instantaneously at rest. At rest momentarily or instantaneously at rest. This 2 meters per second squared means the object is accelerating to the right. So what's happened is this object has gone, starting, if there is the origin, it has moved a certain distance this way. It started here. It's moved a certain distance towards the origin and it's turned back around, and it's turning at time equals to 2. Alright. At what times does the object reverse direction? Find the position of the object at these instants. Alright, it reverses direction, or can change direction, when the velocity is equal to 0. Because if it's going right and then left, or left and then right, there must be an instantaneous point where the velocity is equal to 0. That only happens once. That only happens because we've already drawn the sine diagram at 2. So in D, what's happening is at time equals 2, it reverses. And find the position of the object. Well, to find the position of the object, we sub 2 into here. So 2 into the displacement is 4 minus 8 plus 3 is equal to 1, minus 1. So that is S of 2 is equal to minus 1. Therefore, it is 1 meter to the left of origin. Draw a motion diagram for the object. Alright, motion diagram. 0, minus 1, 3. What happens is starts here, goes there, turns around and comes back. Note, the object isn't actually moving off the path, but to indicate it's gone to the left and the right, we tend to line the paths on top of each other. Alright. At what intervals is the speed of the object decreasing? Okay, here, where the speed is decreasing, will be for this portion here. And then for this portion, the speed will start at 0, but then increase back up. And note, that isn't necessarily because left and right, it's because the acceleration was working at odds with the velocity. And then the velocity started going to the right, so the acceleration keeps increasing. We'll look at another one of those in the next video.